Hi, this is Cindy Schwartz from Vassar College. Today we're going to look at a simple pulley problem. So we have a pulley that has two masses hanging on it as shown in the figure. We're going to take a simple case where we're going to neglect the mass of the pulley and we're going to assume that there's no friction in the problem. Because there's no friction, that means that the tension in the rope connecting the two masses is the same. And so I'm going to label that tension T and indicate with arrows the direction that it acts on each mass. For this problem, we're going to put in some numbers. So the red mass will be equal to 2 kilograms, and the blue mass is going to be equal to 6 kilograms. So before you solve the problem, you may want to think about what direction this system is going to go in once it's released. Okay, so now the next thing that I have to do is I have to choose a direction as my positive direction. So I already concluded that it is going to go this way because the blue one does have a larger mass. So I'm going to choose that as my positive direction. The next step is to apply F net equals MA for each object. So for the red mass, we have T, which is positive, minus the weight, which is mg, is equal to ma. And for the blue mass, we have mg minus t is equal to ma. So make sure you understand why the signs are different in both of those cases, because of the direction that we've chosen as positive. And actually, I probably should put mg on here. So this is mg like that, and this is the other mg. Okay, so now we're going to put in some numbers. For the red mass, we have t minus the mass is 2, g equals 2a. And for the blue one, we have 6g minus t equals 6a. So we have two equations in two unknowns. And we're going to now go on to the next page, and we're going to solve this in two different ways. Okay, so the first way that we're going to do this, which I will call method 1, is probably the most common way that I usually solve my problems. I'm going to rewrite the two equations, t minus 2g equals 2a, and minus t plus 6g equals 6a. And then what I'm going to do is I'm going to add them. By doing that, we can see that the t's go away. So t and negative t gives you a 0, and we get 4g equals 8a, or a is equal to g over 2, which we can put in 9.8 over 2, and we get an acceleration of 4.9 meters per second squared. After that, we need to find the tension, so we can go back to either equation. So I'm going to go back to the first one. T minus 2 times 9.8 is equal to 2 times the acceleration, which is 4.9 meters per second squared, and I get a tension of 29.4 newtons. Okay, now we're going to do this by a second method, which is the method of substitutions. I guess I should call this one method 1. Okay, so in method 2, what we're going to do is we're going to solve one equation for t. And then we're going to put that value of t into the other equation. Okay, so in the other equation we have 6g minus t, I'll rewrite it first, equals 6a, which becomes 6g minus 2g plus 2a equals 6a, because we've substituted this value in for t. And when we solve this, we get a equals g over 2, No surprise, 4.9 meters per second squared. And plugging that back in, we get, for the tension, T is equal to 29.4 newtons. And as we know, we should get the same answer. So hopefully this example was helpful for you. In the end, you can decide whether you like the first method or the second method better. And whichever one works best for you would be the one that you would choose to use for your solving of these problems.